Hello, all. Good morning. Welcome to the first EDA Tech Hub SRI seminar series of this year. Delighted to have you here. Most of you know this quite well by now, but just in case you don't, the Risk and Resilience Tech Hub is a public-private partnership working across the four-county area. And the idea is that we commercialize solutions to our changing relationship to water and extreme weather. So on the right, you can kind of see the areas that the Tech Hub works on. And a lot of it is to do with reducing barriers to adoption of technology related to resilient concrete, such as what Atorod will be talking about, or advanced materials, clean cement fabrication, wall of wind testing, providing testbed services, etc. It is one of 31 federally designated tech hubs, and the projects and the leads are given in the slide here. Ultimately, this is all about economic development. I want to clarify that this isn't a research project per se, and also to develop our workforce to result in good jobs, in thriving startups, resilient economy, and stronger national defense and security as well. So this is a broader picture of what the Tech Hub is interested in, and you can see that there's a number of things here related to concrete, coastal, energy efficient buildings, etc. If these are things that interest you, come talk to us, come work with us. We're always happy to assist. We're always happy to make connections, and we're always interested in ultimately growing the South Florida ecosystem and economy. The call that you are in is the SRI seminar series. It is one part of this big adventure. And the idea of the seminar series is to educate and bring awareness to high TRL technologies, to ultimately accelerate their adoption in real life, to disseminate information on both high and low TRL technologies to increase the TRL, to establish connections between various stakeholders, and to advance startups and technologies. And the technologies can come from startups, from industry, or from academia. Here is the list of seminars. As you can see, we have a full exciting lineup for the next several months. Today, I'm really delighted to have with us Professor Atorod Azizinamini, who is at FIU. He has way too many accolades for me to go through, but he's the Director of Infrastructure Research and Innovation at FIU, also the Vasant Surti Professor of Civil Engineering. He's also Director of IBT, ABC, UTC. Most of you should know what the UTCs are. And today he's going to talk about sprayable ultra high performance concrete, a game changing technology. So thank you very much, Dr. Azizinamini, and the floor is all yours.
All right, thank you, Pranoy. So I hope that I'm going to show you my slides in a minute, and I thought what we are going to discuss sprayable UHPC in detail, but also what I would like to do is to give you some background on ultra high performance concrete, what it is, and then go toward basically the applications, the properties, and then the sprayable UHPC. Kind of give you the story of the what the UHPC was and how we got to the sprayable UHPC, which is really game-changing technology, in my opinion. At the end, I like to leave. Actually, I'm going to watch my presentation time because I like to have some time so that we can have some dialogue. I'm pretty sure that there's going to be some questions, and I will do my best to answer. And if you don't get a chance, please, I'm going to leave you my email address and my contact information, and by all means, please reach out. Now, UHPC probably has had more application or ultra high performance concrete in outside the US, especially in the Europe, and now in like countries like Malaysia. And I will show you some applications. So before I dive into the material properties and so on, which is going to lead me to the sprayable UHPC and the 3D printing and all that, I wanted to show you where it's been used. Malaysia, actually, believe it or not, Malaysia is one of the countries that have used UHPC quite a bit. In fact, Dr. Wu, who is owner of a company in Malaysia, they have constructed, I talked to him just about a month and a half or so ago, they have constructed more than 400 UHPC bridge, which is really mind-boggling. I think they've constructed more UHPC bridge than anybody else in the world. This is one of them, long one, 320 feet, 28 feet long girders. So how they transport that to the site, that's a very interesting question. In the US, there is actually Federal Highway Administration has an interactive, and I'm going to give you the PDF copy of all my presentation. You will see a link to the US DOT map that shows by year. You can plot the data in different form. You can see how many bridges have used UHPC in one form or another. Okay, so sometimes it's just a closure joints, sometimes it's for minor repair, sometimes it's just a whole girder, sometimes it's a deck and so on. But I don't believe the FHWA is not able to keep track of it. After 2015-16, it really just blossomed, so it's everywhere, basically. Back in the 2006 or so, I mean, it was like a demo projects or something like that, but not anymore. There is actually, if you happen to go to Turner Fairbank in the DC area, there is a so-called Pi Bridge that I think was developed by the faculties at the MIT. So they have a bridge that as a demo, kind of. One of the first one that was constructed in the US in the bridge area was in Iowa. And by the way, UHPC has been used extensively in the bridge area right now, so the bridge owners are very familiar. It hasn't really found its application in the building area, even though I think UHPC is going to have more application in the building area than the bridge. In fact, with the help of the two very established high-rise building designer, we redesigned an existing 42-story building that was designed using a conventional concrete. We redesigned it using a UHPC. And there is a significant economy. The size of the shear wall, the column size and things like that goes down. And more importantly, the total weight goes down, the foundation size gets smaller. When the size of the columns and the shear wall gets smaller, then you have basically the rentable space is increased, and the architect and the owners love that. So I think it's going to have a more application in the building area rather than the bridge, but it hasn't found it. In the case of the bridge, it's been used mainly closure joints. Basically, this is the ABC application where you bring this big segment of the bridge that you construct offsite, and then you put them side by side, and then you join them. This is one bridge that we developed, basically, and it's a job in Pennsylvania. In Europe, they have used it for retrofit, cast-in-place version, not the spray. Cast-in-place, and the thing is that this, when you wrap an existing bridge or column or something with the UHPC, the end product actually sometimes becomes even much better than the original structure, because the material is very durable, and we will discuss that, and it is very strong. I mean, we are talking about 25, 28, 32,000 psi concrete in 28 days. One of them, I went kind of scanning in Switzerland, because a good friend of mine, Eugene Bruweiler, in Switzerland, is one of the pioneers in the UHPC area, and he showed me some photos that, for example, the one on the left-hand side is a liner. They put a UHPC liner, and they are basically stored in a hazardous material. It's very flowable. You can see it's very flowable. You don't need to vibrate it or anything like that. This is a cast in place. We're going to discuss the sprayable, which is really the game-changing technology, like we said. Retrofitting the columns, things like that. There's a tremendous amount of application. So let me just give you some introduction to it. The upper portion shows you the relative size of the aggregates and everything compared to the conventional concrete. The bottom side is a conventional concrete. As you can see, there is no coarse aggregate. There's lots of steel fibers. In fact, if you notice, you can see maybe some steel fibers here. In fact, 1 cubic yard of UHPC uses about 250 pounds of steel fibers. These steel fibers are 13 millimeters in length, 0.2 millimeters in diameter, and they're 400 KSI. Very strong. It's got a little bit of about a year and a half ago, Hyperfiber, who provides the steel fibers in Detroit, Michigan, they provided a little bit of a dent on the steel fibers, but previously it was just smooth. And that there is a reason why it shouldn't be like a hook at the end, and so on. If there's a time, we can elaborate on that. Properties, just again, I'm going to give you the copy of the slides. I'm not going to go through everything, but look at over here. The tensile capacity is very high. Compressive strength is very high. There is a shrinkage involved with this thing, a little bit higher than the conventional concrete. Specific creep is a little bit lower, which is good because there's not that much water in that thing. Thermal expansion coefficient is a little bit high compared to conventional concrete. So I'll give you some property, you can look at it. One of the main aspect of the UHPC is that its modulus of elasticity is very high. Now, you can measure, actually you can, let's say if you want to apply to a building, you can actually measure the modulus of elasticity. And if you measure it, it's going to be higher than some of these equations that are around will give you. I mean, we are talking about modulus of elasticity of like 9,000 KSI. So when it comes to a building, the drift of the building in a high-rise building is very important. And the modulus of elasticity plays a major role. So that's where the major advantage of the UHPC comes in for the building application. In the US, we define, according to the Federal Highway Administration, a concrete that has good tensile capacity, post-cracking capacity, and a strength not larger than 17.5 KSI. That's how it is defined in the US now. This is a slide. Don't worry about everything else. Basically, the vertical axis, okay, if the lower the numbers, the horizontal axis is the number of the days that are exposed to a salt contaminated water, and the vertical axis, take it as the sign of the lower it is, the better it is with respect to how fast the salt water or so ingresses inside. Okay. Now the left hand side is a normal strength concrete. Right hand side is a UHPC. You can see that even after 450 days or so, in the vertical axis for UHPC still is very low. That means that the salt water really has a very hard time to ingress inside. That's what the really main advantage of the UHPC for resiliency. The other aspect is that UHPC, once it cracks, because there are lots of steel fibers in there, those steel fibers kind of holds on the crack and it doesn't let the cracks open until one crack takes over. Okay. So here is a stress strain curve. You can see that once you load it, there is a multiple cracks, and then there is a one crack that takes over. Okay, one crack that takes over. Okay, and that's when we calculate. We say that's the capacity of the section. I can show you here. For example, this beam that we wrapped it with UHPC. First, when you load it, you get a multiple cracks. Then one crack that is located at the maximum moment point takes over, basically opens up. Once that big crack or crack localization take place, then the other cracks doesn't open up. And that's really, we define at that point, we say that's the ultimate capacity of it. Let me give you some idea on durability. We have actually developed these techniques that in 10 minutes you can kind of evaluate different relative durability of a different type of concrete. So what we do is you take a cylinder and then you apply very high pressure, water pressure to it, and then you watch the for example, by time how the pressure changes. So if you put a cylinder under 1 foot of water, that will create about 0.433 psi pressure. So if I apply pressure, like 200 psi pressure on top of that cylinder, that will be similar to putting that cylinder under 460 feet of, let's say, water. Okay. So we have tested like a cylinder that's made of UHPC and normal strength concrete, and take a look. With the UHPC, you apply 200 psi water pressure. By time it doesn't change, whereas normal strength concrete, that water just sips through. Okay, so that's why UHPC is durable. We've done lots of freeze-thaw tests. After even 365 days, 400 days, there's absolutely no change. Now, in Florida, we don't worry about the freeze-thaw, but in the Northeast, we do. Very durable material. We've done tons of rapid chloride permeability tests, the same information, basically. We have actually sprayed the UHPC or cast in place UHPC on top of a normal strength concrete. And you can see that with the rapid chloride permeability test, which is, by the way, it's not a good test for the durability because of a steel fiber, but nevertheless, look at here. All of a sudden, even if I put a half-inch UHPC, spray or cast in place, all of a sudden, the number of the coulombs goes very low, below 300 or so. So we have done some very relatively smaller amount of the fire test, and I can tell you that the fire test basically, we don't know the mechanism, but up to, if you cook the, let's say, small cubes of UHPC up to 300 degrees Fahrenheit, and then do a compressive test. Actually, the compressive test increases, but if you cook it more than, let's say, 800 degree for a couple of hours and then test it under the compression, then it does go down, the compressive capacity. So, but the same behavior, actually, some of our colleagues in Canada, they called us and they have seen the same thing. But the mechanism, there's some explanation, but the work that we have conducted with the fire is very relatively small. There's more work needs to be done in that field. So let me show you some of the applications. Okay, partial repair of the concrete column. We've done tons of testing. Now there are some, you can repair columns, let's say bridge columns or building columns. You can wrap it with FRP, with the concrete, with the steel elements. But one way is to wrap it with the UHPC. So we've done lots of testing with this thing. And one thing that we have found out is that if you fix, so here, for example, you can see some specimen that intentionally we didn't cast the bottom portion of it, representing some damage, and then we wrapped it with the UHPC. And one lesson that we have learned is that any place that you wrap the column with the UHPC, okay, if you do it correctly, you shift the damage above that area, because UHPC is so strong that doesn't let any, you do get some hairline cracks, but you shift the damage to somewhere else, above or below. So that means that if you retrofit in a column, you also have to retrofit the little bit around the column in the base, because if don't, you see the left-hand side? In fact, we learned it the hard way. If you don't, in the left two columns, we didn't retrofit the base, and the failure was in the base because that's where the maximum moment is. Then in the next one, the next two, we also fixed the basically repair the foundation, and then now we shift the damage to the above. We have also looked at, like a champagne tower. Now, all these things that I'm showing you, we can do a spray now. We can do a spray, not cast in place. We have done some tests. We have taken some, let's say, 10 by 10 inch concrete columns, and we wrapped it with normal strength and with UHPC. And we've added. So this represents repairing columns, high-rise buildings. Okay, and it can be done now with a spray method. So let me show you some results. Here is you see a load deflection curve. The green line is a 10 by 10 inch reinforced concrete column. The red one is if I wrap it with a normal strength concrete, couple of inches. And then the black and the blue is if I wrap it with the UHPC. So you get the ductility, you get the strength, very nice behavior. One of the very interesting work that we are just starting is there are some in the buildings or a bridge that you have a steel columns that needs to be retrofitted, maybe due to the corrosion, maybe the function of the structure is changing, and then you need to beef it up. So what we are trying to do is take a steel, this is actually to test a specimen that we're going to be casting very soon. We are going to be spraying the steel column with the UHPC. But before we do that, we're going to provide we're going to wrap the cross, you see the cross section, we're going to wrap it with the UHPC, but before doing that, we're going to add some longitudinal reinforcement and then also some stirrups in a shape that goes around the column, okay? And then once it comes, then we're going to test it. So it's going to be a very interesting test. So, and the way we're going to do at least 2 tests to start with. One, cast the UHPC, one, spray the steel column with the UHPC after placing the longitudinal reinforcement and basically the stirrups. Very interesting. I've not seen any work similar to this, but it's coming up. And here is a specimen. The foundation of it is ready to go. Another experiments that we've done is strengthening the timber piles with a UHPC. Again, this could be done cast in place or a spray. And you can see I'm going to show you here. So we took I think this is like a 9 inch in diameter timber piles. And when you test it without any strengthening, like we got, in this case, 345 kips. Then we wrapped it with the UHPC, 1.5 inches or 2. We got no reinforcement, we got 692. Then we put a little bit of a confining reinforcement and so on, we go 715, okay? And then we also looked at the long column, the length effect. So you can see that wrapping a timber pile with just 1.5 inches of the UHPC, you go from 345 to 715. So this has an application. We can do a spray, we can do a cast in place. It has a very fast, and it also has a very, you can increase the capacity by 2, and then also you can use a timber pile as a formwork. And even if it's in a bad shape, don't worry about it, because you can rely on the strength coming purely from the UHPC, not from the timber piles. We've done quite a bit of a test trying to strengthen the beams, the flexural capacity of the beams. So there are many ways of doing it. We played around. This was 5-6 years ago, more than that actually. And we tried to see that, okay, if I have a damaged area, what do I need to do in order to get the UHPC to be attached to the normal strength concrete? What we found out is that we tried to put some mechanical devices to give a good bond. There is no need for that. All you have to do is sandblast the area that you want to beef up its capacity, shear or a moment, and then expose the basically the aggregate before a spray or cast in place. Make sure that you have the surface is wet, and then that's all you need to do. Okay, so we've done quite a bit of a test. If you are interested, let me know. I can share with you more data. Here's some of the tests that we've done, and very nice behavior. So here is just a no as is the flexural beam, and then the rest of the curves is if you wrap it or that cover the damage area with UHPC. Another very interesting one, we took a T-beam and wrapped it with the UHPC. This T-beam represented actually a Venetian causeway girders. And we wanted, because at the time, this was several years ago, we wanted to show that the cheaper way to fix the Venetian causeway bridges is really wrap it from the bottom. We can spray it with the UHPC. From the top we can cast in place, and that adds quite a bit. So we did experiment. We took a T-beam, you can see over here the T-beam, and then we put some additional reinforcement. Here is a T-beam, and then we sandblast it, we put additional reinforcement, and then we put in the actually epoxy glass formwork, and then I can show you here. You can see we pour the UHPC, and the UHPC flows in a very small area. You see it was a glass formwork, so we could see it very nicely. No honeycomb, nothing. You can see how it flows. There's no need for vibration, nothing. And then we tested. So now, coming back to a sprayable UHPC, we've done quite a bit of a test to understand the property of the structures that are sprayed with UHPC. We took some small beams, ASTM size, standard ASTM test, and then we cast in place or sprayed UHPC to it, and then we did the flexural test by putting the bottom in tension. And you can see that modulus of rupture or tensile capacity of the bottom side of the beam without any reinforcement. You can see from like a 700 or so, it goes to 1200. This is just to cast a very thin layer, 1 inch or so of a UHPC, or spray the UHPC. By the way, there is no difference between them. That can add quite a bit to the strength, tensile capacity. We've done direct tension test. We've sprayed or cast UHPC on top of normal strength concrete, and then we've done just a pull test. And and these are some of the examples of it. I can tell you, we never see the failure to take place at the boundary. It's always at the normal strength concrete. There was a couple of cases where the failure took place at the boundary, but the reason for that was because there was still reinforcement, so the surface area was decreased. But this is something that others have reported too. If you prepare the surface correctly, and at the time of the spray or cast in place, you make sure that the surface is wet, because UHPC doesn't have too much water in it. It's a water cementation ratio is a 0.18, 0.2. And if you don't keep the surface of the normal strength concrete wet, it's gonna soak all that small water from the UHPC, and then you're gonna get some shrinkage, cracking, things like that. So if you prepare the surface correctly, there is no concern about the bond, which is a very good news. These are some data. I will go through it. This is we've also have done a sprayed again or cast in place, and we have prepared the small specimens and then have done the RCP test. You can see that how the RCP value reduces very significantly. We've done some relatively large scale tests, 8 foot long, 12 inch by 12 inch, basically beam, cast the UHPC or spray the UHPC, and then test it under the flexure. And these are some of the beams. Here you can see basically. And now, if you look at here, this is just a normal strength concrete. Okay, so just keep the number. So the capacity was about 35 kips. So this is like an 8 foot long beam that was tested under the Flexural basically, but just point loading, and normal strength concrete, nothing added, but 35 kips. Then we sprayed it with the UHPC about an inch and a half, and or companion cast in place. So first of all, there is no difference between the spray or cast, because both of them give you about, let's say, 45 kips. Okay. In fact, spray gives us a little bit higher, and ductility didn't change or anything, but 45. So you can see that the capacity increased from 35 kips to 45 kips by just spraying or casting a UHPC in the bottoms on the tension side. The first field application, some of you know, the first field application in the US for a sprayable UHPC was done by us in August of 2024. We worked with Virginia Department of Transportation to basically fix an abutment of two bridge. This is the bridge, and this is the two abutment. Actually, we didn't take too much material. We took all our equipment to Washington, D.C., all our equipment. We took the materials, and you can see from here. And our equipment right now is completely changed. The equipment that we used in August of 2024 was what I would call lab version. Right now, it's a very sophisticated, very heavy-duty construction type. And here you can see the spray basically during the August of 2024, spraying the UHPC, and they gave me the honor of being the nozzle man. In that, now the spray is the process is automated. I'll show you. So here is another one. The other good thing about the sprayable UHPC is that you can go several layers. So the way I do, I go from one end to another end. I wait maybe a minute or two, and then I go second layer. You can go up to a couple of inches. So no need for formworks or anything. Now here is you can see the spray, and this is the August of 19, 2024, and this is the January 6, 2025. So the end product is very nice. It's clean, aesthetically, and so on. We do have two projects that's coming out with the sprayable UHPC in New York and DOT. So we are working with New York Department of Transportation and Pennsylvania Department of Transportation to fix steel culvert. Now here is a lab work. Okay, you can see that you can spray this, and that UHPC sticks to steel too, very nicely. You can do overhead. Okay, so you can spray these things overhead. The two bridges that we are going to be fixing is going to be in New York. Basically, we are going to fix the invert, or New York DOT is going to do. The invert is going to be fixed by normal strength concrete, and then we are going to basically roughen the surface. But then we are going to spray the entire 57-foot long culvert all the way around with the UHPC. That's coming up in June of 2026. And then another one is going to be strengthened. So it's got a sidewall, and there is no need for the invert in this case, but we're going to be spraying with about a couple of inches with the UHPC all the way around, also the sidewalls. The spray is going to be gone. This equipment that you see is going to be at FIU on this Monday, we are told. It's coming this Monday, and then it's going to be operational in a couple of weeks. So what you do is basically with you see the worker standing on the right hand side with the joist stick. So it's going to be much easier than what we did in the Washington. So this one has got a boom. It can extend, and that basically this is a robot, but you need a pump that basically pumps the UHPC into this robot, and then the robot sprays it. Okay. and of course you need an air compressor. It's like a shotcrete process, so you need a air compressor at the nozzle level, and here is you can see the nozzle level, and the air compressor is basically is included in this robots. So this project, by the way, is funded by the Federal Highway Administration's AMR project. We were selected. The contract, the paperwork is not complete. This work will be done through the FIU. Is a 2 demonstration type project, which also helps basically the Miami-Dade TechHub, basically the projects that we have. I also wanted to share with you the 3D concrete printing that uses the sprayable UHPC. Now, you guys know that the 3D concrete printing layer by layer is a very popular, conventional. The problem with one of the problem with the layer by layer is the bond between the layers, and because the cross section is smaller too. So we have purchased this particular 3D printer that we can print a full scale structure. So here is the printer that we have purchased, that we can print a multi-story building. Actually, you can visit the FIU and I'll be happy to show you. This is basically sitting on the slab that we built, the 3D printer, and this is the house that was not here, actually in the Europe, that was printed using that printer. And one of the application of this thing is of this 3D layer by layer and the UHPC spray is to formwork. I mean, I can build a formwork out of the, let's say, printed using a layer by layer and then spray with UHPC, and that makes it really resilient. So I won't go, and then spray it, basically build a formwork or any structure, seawall. I think the seawall is going to be a very big application, and in fact, we are trying to get our feet in that field, because I think we have a very great concept that we can print a seawall using a layer by layer and then spray the UHPC. That will allow us to decrease the section size, make it more resilient against the salt water to penetrate through it, and it's going to be easier to ship. It's going to be lighter, using less material, more sustainable, and more resilient, more importantly. So that's at the TRL level of 6-7. I mean, it really won't take too much time. So the resilient seawall system using a layer by layer 3D concrete printing and sprayed UHPC, I think is going to be a game changer. Okay. Now, upcoming stuff that we have is we have a training. Basically, we are going to be training the contractors as part of the funding that we have received from the TechHub, basically, and workforce development, technology transfers, and so on. Now, one of the things that we are doing right now, we are getting ready. Actually, we are going to be buying now this picture is not what we are going to be building, but we are going to have a trailer that's going to have a mixer, air compressor, pump, the robots that can go to the site and then do a spray UHPC. We are going to subcontract the removal of the contaminated concrete, but then we will have all the equipment that's necessary to go to the job sites and then spray it. Now, that whole spray process, that's something else that there is so many steps that you have to be really careful with it to make sure that every step is done correctly. In order to learn it, really, you have to have a hands-on experience. It is not something that you can just listen to my presentation or somebody else's presentation and then be able to do that. Okay. Of course, this sprayable UHPC has been in the media. I just put, from the Federal Highway Administration to some magazines. ENR had a very good article on this sprayable UHPC. And we were lucky to actually, the sprayable UHPC was selected as the engineering news record of top 25 2025 newsmakers of the year for the sprayable UHPC. Now, also lots of people ask us, okay, so who can provide this service for the sprayable UHPC? So now we have the uh, uh, startup company called the UHPC Technologies. There is a website, and if you are interested, actually I asked Carlos Rodriguez, who is with the UHPC Technology, to attend this. So he's there. He could be your contact person. And through this UHPC Technologies, basically the sprayable UHPC services is going to be provided. There's a website. You can just type UHPCtechnologies.com. You can take a look at it. That provides the service, and also it's going to provide basically very soon sell the actually material in a pre-bag portion, very similar to what you see like a ductile or so, that you can take all the dry materials and steel fibers, and then with the recipe that they will give you, you can fix it. Basically, you can make the material. Also, I wanted to share with you, right here in Miami, at the Hyatt Regency Hotel, December 1st and 2nd, we have our World Bridge Engineering Conference. I don't know how many of you have attended. These past conferences were held in 2014, 15, 17, 19, 21, 22, 24, and the next one is going to be 26. Usually about 700 bridge professionals attend these conferences. It is co-sponsored by 33 State Department of Transportation, and it's a very big event. The deadline to submit the abstract is March 20. So anyway, I think on 10:43 I wanted to finish at before 10:45, so we have a little bit time to question and answer period. So Pranoy, that's all my presentation. So hopefully we'll have about 50 minutes or so for question and answer.